Hi guys, I hope you guys are doing really well. I thought I might just create a little lesson video while you're away doing the distance learning. And this is a new coursework video on chapter one. So this is the next chapter that we need to push on despite the situation that we're in. So this is chapter one called Sequence and Series, and this is the chapter that we need to, like it's another like a 2 unit or standard maths questions. Chapter. So I've selected some sample questions from chapter one, section A, and as usual, before you watch this video, make sure you have done your reading of the theory and the examples of section 1A. Otherwise, this video wouldn't make any sense. So make sure you do that if you haven't done so now, and then come back to this video to watch the rest of it. And, in any part of this video while watching, you can, stop and pause and, do the questions yourself if you wanted to. And so you don't have to watch the whole thing from start to the finish. All right, so question 3A. So you're given this equation or for the sequence. By the way, this sequence Tn, that means you can think of that as T obviously means term and N means the nth term. So it's Tn means the nth term or the general term in the sequence when you can spot a clear pattern or the mathematical pattern behind it so that you can write it down as a mathematical formula. So you can think of this Tn as if it's a function. It exactly works the same way the function notation. So you can think of this as T of n. So it's a function of n basically. And obviously here in dealing with any sequence questions is that this n has to be a positive integer, obviously, because we're talking about the first term being t1, second term being t2, and so on. So you can't have two and a half, like in the order of one and second. So you can't have one and a half term. Okay, so if you see what I mean. Okay, so all these numbers have to be a positive integer. So the first question here was basically asking like, what are the first four terms in the sequence? So that's obviously all that, following the recipe there. So that's okay. All right, question 8. This here, and then, okay, so again, there's the general nth term formula there. And you were told that when this term is, we don't know which term that is, but it's happened to be 30. And if and then the question is asking, is 30, the number 30, can really the number 30 be part of this sequence? Well, let's have a look. If that is part of the sequence, then that equation should satisfy. So which is this, and therefore 3n has to be 29, which means n is 29 over 3. But, like I said, if it's a sequence, this n has to be a positive integer, okay? Because we're talking first, second, third, fourth, fifth term, not 5.5 term. That doesn't make any sense. Okay, so therefore 30 cannot be part of the sequence. Question 9. Okay, so part B, there are two cases. Given the formula for the general or the nth term of the sequence, and we want to figure out whether 40 is a possibility as part of the sequence. And the second one was, can 72 be part of the sequence? Well, let's have a look. So that means we now have to solve this equation here, okay, which gives you that, okay. But that means whenever you take the square root of 20, and because it's not a perfect square number, you have to take the square root of that, which is root 20, and we know that that's not even a rational number. So therefore, we can straight away see that 40 is not in the sequence. Similarly, when you set that up to 72, then you get that equation. But 36 is a perfect square number, so n is 6, which means it's the sixth term in that sequence that gives you 72 as the term value. So therefore, there we go, that's sixth term gives you 72. So hence 72 is actually the sixth term in that sequence. So that's how you figure that out. All right, moving on to the next set of questions. I've picked question 10. So here's Tn, the general nth term formula is 10n plus 4. And the question is saying, what is the very first term that appears that this term becomes greater than 56? Then you basically have to solve that inequality, okay, which is that. And that's a nice linear inequality to solve for n, then you get this. Okay, now, according to inequality, it says n has to be greater than 5.2. So then next largest, sorry, not the largest, next smallest positive integer value that satisfies this inequality is 6. Okay, so hence we can conclude that n equals 6 is the first n value that satisfies this inequality. In other words, in terms of the sequence, it's actually the sixth term. Okay, all right, so that is the very first time when this number, when a term in that sequence becomes greater than 56. So which turns out to be 64, because if you put the 6 back into that formula, the nth term formula, they give 64. So that's the very first number in that sequence governed by that formula that is actually greater than 56. Any term before sixth term, in other words, term 1, term 2, term 3, term 4, and term 5, a fifth term, they're all less than 56. Okay, so that's what that means. All right, question 12. So you were told this is what we called recursive formula. Okay, I hope I spelled the word recursive correctly here, but you can always look that up. So it means it's a recurring formula. So that here you must be given the t1, the very first term as a given value, and then all the other ones is generated by the relationship between the nth term and the term before, or the n minus 1th term. Okay, so therefore it recurs the pattern. Okay, it's a bit of like mathematical induction, but it's in a different sense. But that's this second line sort of tells you the actual pattern. Okay, so what that means is the term that you're dealing with is actually half of the previous term. That's what it means. Okay, so if I follow that, t1 is 20. That's the first term. Then t2. So this is now where you use the second bit of the recursive formula. Okay, so put the n equals 2 in there, then that means half times t1 according to that formula. So we know t1, that's 20, so that's 10. And you do this, repeat the same pattern. So t3 is half of t2, and we know t2 to be 10, so that's 5, and t4, and so on. Okay, so that's how you interpret any recursive formula. Question 13b. So it's now the other way around. Given a pattern or the sequence or the progression there, can you now write down the recursive formula? Okay, so we notice that that's multiplying by 2. Okay, you could argue, well, 7 plus 7 is 14, right? But then again, remember, it has to have the same pattern. To go from 14 to 28, you have to add the 14. So these two don't form the same pattern. So that therefore this can't be the option. Hence you have to think about other ways to come up with the same pattern, which is this one. Okay, so definitely you have to give the initial value for it, which is that, and then write down the second part of the recursive formula, which is that. Okay, it's the nth term is double the previous term. So notice here 28 is double of 14, and 14 is also the double of 7. So that's how you write down the recursive formula for that particular question. All right, question 15. Okay, so this is now, again, sort of inequality question. So you were given the general formula for the sequence, and you want to figure out when is the first time that a term in that sequence is less than 18. Well, this is then you got to focus on that inequality to solve. Unfortunately, this is a quadratic inequality to solve. Luckily, it's a monic, so that gets down to that. And lucky enough we can get that factorized easily, quite easily, like so. Okay, now that's less than 0, meaning that's below the n axis, okay, because we're using the prenumeral as n, okay. So if I sketch this guy here, the left-hand side, okay, you can think of that as y equals n minus 6 times n plus 3. That's concave up because the leading coefficient here is positive, so that's that parabola. And then the two n intercepts, which is minus 3 and 6 from those two, and it's concave up. So, and then it's below the part of the curve that is below the n-axis, which is obviously between minus 3 and 6, not including those two n-intercepts. So then you get that. But we know that n here has to be a positive integer, right? Because you kind of negative 1th term or negative 2th term. You know? So therefore, you can get that, and it's a positive integer, so the only options are 1, 2, 3, and 5. So there are 5 terms that are less than 18 in that sequence. All right? All right, so now the last question that I picked is question 18. So given that as the general formula for that sequence in the nth term, okay. First part, you were asked to figure out the actual sum of the 4 terms. So following that pattern, you just go substitute n for 1, 2, 3, and 4, so on. Okay, to get that. Okay, so that's T1, T2, T3, and T4. All right, but have a look at the pattern here. This negative half gets cancels with this half. Negative third cancels with that third, and so on. Okay, so you can see that, okay, only the first and the last term survive. So that's one takeaway. Fifth, which is 4/5. Okay. All right. Now extend that idea, and then we're trying to, okay, not only the first 4 terms, we want to figure out the sum of the first n terms, if you like. Okay. So write that down. Okay. And then the general nth term, take that. But have a look at the pattern. The pattern is the second term in the previous term cancels with the first term in the term that you're dealing with. So that cancels with this. That, if you repeat the pattern, cancels with the first term in the term, the nth term that you're working with. So it's just like in the previous case, it's the first and the last, don't want to say terms, but the first term in this and the last term, second term in that nth term gets survived. So then you get this. And again, if you do the common denominator exercise, then you get that. Okay. And finally, part B is this, to show that first of all, this is equal to that. Well, that's just a simple, hopefully simple, common denominator exercise, which is this, and then that. Okay. All right, and then you were given that the nth term is given as 1 on 30. Okay, so now what do we do? So we use that and set that equal to that. Okay, because we've figured out the Tn, which is given initially like this, is actually the same with this. So that's that equation to solve. And that's that. Again, nice quadratic, monoquadratic equation to solve in terms of n. And that's that one. Okay, now here, yes, initially n could be -6 and 5, but like I said before in this video all the time, is that n has to be a positive integer. So the only possibility is 5. Hence, it's the 5th term that makes this sequence to be 1 on 30. All right. All right. So I hope this video helped you appreciate some of the questions from 1A. I know it's been just one-way talking, but again, that's what we can do at the moment. So make sure you go over these videos, this video again. And I'm planning to do more of these videos as we move on to the new sections each time. So look out for that and look forward to that as well. And also make sure you do your own reading of the examples and the theory of each section that I'm putting up. All right, I'll see you guys next time.